Welcome back on my channel. We will continue physics class 12th and the chapter is nuclei. Okay, so now I am continuing the size of nucleus. Size of nucleus. As we have seen in chapter 12, Rutherford was pioneer who postulated and established the existence of the atomic nucleus. Yes, continue. Okay, we will continue. See. Continue. Rutherford suggestions Gregor and Mosden performed their classic experiment on the scattering of the alpha particle from the gold foils. Their experiment revealed that the distance of the closest approach to a gold nucleus of an alpha particle of kinetic energy 5.5 mega electronic volt is about 4 into 10 to the power minus 14 meter. The scattering of alpha particle by the gold sheet could be understood by Rutherford by assuming that the Coulomb repulsive force was solely responsible for the scattering. Since the positive charge is to the conformed to the nucleus, the actual size of the nucleus has to be less than 4 into 10 to the power minus 14 meter. Okay, it was alpha particle of the higher energy is than 5.5 electron volt. The distance of closest approach to the gold nucleus will be smaller, and at some point the scattering will begin to be affected by the short range nuclear forces and differ from Rutherford calculations. Rutherford's calculations are based on pure Coulomb repulsion between the positive charges of alpha particle and the gold nucleus, from the distance of which deviations set in nuclear size can be inferred. Okay. By performing a scattering experiment in which fast electrons instead of alpha particles are projectiles that bombarded targets made of the various elements, the size of nucleus various elements have been accurately measured. Okay, it has been found that a nucleus of a mass number A has a radius r is equal to r0 in a to the power 1 upon 3. Okay. Where R0 is 1.2 into 10 to the power minus 15 meter will equal to 1.2 FM, and 1 FM is equal to 10 to the minus 15 meter. FM for me. This means the volume of the nucleus, which is proportional to R to the power 3, is proportional to A. Thus, the density of nucleus is a constant independent of A dash for all nuclei. Different nuclei are like a drop of the liquid of the constant in density. The density of nuclear matter is approximately 2.3 into 10 to the power 17 kilogram per meter cube. This density is very large, okay, compared to the ordinary matter, say water, which is 10 to the power 3 kilogram per meter cube. This is understandable as we have already seen that the most of the atom is empty. Ordinary matter is consisting of the atoms has a large amount of empty space. And this is the example you have to do yourself. The next one is, next subtopic is mass energy and nuclear binding energy. Now, mass energy, we will see. Easy to get in? Okay. Okay, the next one is Einstein showed from his theory of the special relativity, is it is necessary to treat mass as another form of energy. Before the advent of this theory of special relativity, it was presumed that mass and energy were conserved separately in a reaction. However, Einstein showed that mass is another form of energy and one can convert mass energy into other form of energy, say kinetic energy, okay, vice versa. So next one, Einstein gave the famous mass energy equivalence relation E is equal to mc square, where the energy equivalent of the m is related to the above equation, and c, the velocity of light in vacuum, is approximately equal to 3 into 10 to the power 8 meter per second. This is the question, do yourself. Next, experimental verification of the Einstein mass energy relation has been achieved in the study of the nuclear reactions among the nuclei, electron and other more recently discovered particles. In a reaction, the conservation law of the energy states that the initial energy and the final energy are equal provided the energy associated with the mass is also included. This concept is important in our understanding nuclear masses, okay, and the interaction of the nuclei with one another. They form the object matter of the next few sections. Okay, any trouble? Okay, the next subtopic is nuclear binding energy. Okay, in the section 13.2, we have seen the nucleus is made up of the neutrons and protons, there it may be expected that the mass of nucleus is equal to the total mass of individual protons and neutrons. However, the nuclear mass m is found to always less than this. Example, let us consider of O, atomic number 8, atomic mass 16. A nucleus nucleus with has 8 neutrons and 8 protons. Mass of 8 neutrons, 8 into 1.00866 unit. Mass of proton, 8 multiply 1.0727. And mass of electrons, 8 into 0.0055 unit. Therefore, the expected mass of the oxygen nucleus, 8 multiplied 2 into 2.0153993, will equal to 16.12774 unit. This is so boring. What we call as, these are the calculation only, not a whole chapter is boring, because the multiplication is just multiply and multiply, continue. The atomic mass of the O, oxygen found mass spectroscopy experiments, is seen to be 15.9999 and round of 16. Subtracting the mass of the electrons, 8 electrons, 8 into 0.00055 unit. Okay, from this we get the experimental mass of 8 oxygen nucleus to be 15.99053 unit. Thus we find the mass of the oxygen nucleus is less than total mass of substituent by 0.1369 1 unit. The difference of in mass of nucleus and its constituent delta m is called the mass defect and is given by delta m. Okay, z mp plus a minus z into mn, bracket close, minus m. This is the formula. Okay, keep in mind. So next one, Einstein's equivalence, the mass of energy and plays a role since the mass of the oxygen nucleus is less than that the sum of the mass of its in the constituent 8 protons, 8 electrons in oxygen. In the unbound state, the equivalent energy of the oxygen nucleus is less than that of the sum of the equivalent energies of its constituencies. If one want to break the oxygen nucleus into 8 protons and 8 neutrons, this extra energy delta m c square has to be supplied. This energy required if B is related to the mass of defect by EB is equal to delta mc square. And the next one is, if a certain number of neutron and proton are bound together to form a nucleus of a certain charge and mass, an energy EP will be released.